if you're given an angle that you want to convert that doesn't fit in, isn't one of those kind of those special angles like 60 degrees or 120 degrees. If you want to convert degrees to radians, what I would suggest is using a proportion, just like you do for any, for converting any other kind of units. If you want to convert, I don't know, feet to meters or meters to feet, if you have 2 meters and you want to convert that to feet, you might use a proportion like this and say 1 meter is equal to 3.3 feet. If you know that conversion factor, so 2 meters is equal to x, and you can solve that proportion for x. That's one way of doing it. I'm not saying this is the only way of doing it, but using a proportion is good. Some of you will just learn the conversion factor and then just multiply or divide accordingly. For this, the conversion factor is 180 degrees is pi radians. That's the conversion factor you need to know. So if you want to convert, let's do, I don't know, some random number here, 73 degrees to radians. You could do it a lot of different ways. You could use a proportion by saying 73 degrees compared to x, I don't know, or radians, or whatever you want to call it, is equal to 180 over pi radians. And then just solve the proportion for this. I'm assuming you can solve a proportion. Probably this proportion would have been better if we had written this on top, which you could do, of course. You could put that on top if that makes more sense to you, because then you can solve more easily for x. How do you solve that proportion for x? Yeah, I mean, there's different ways. I would just do it by multiplying both sides by 73 and putting this up here. Not the line, but times 73 degrees there. Maybe you do it by cross-multiplying. It doesn't matter to me how you do it. Some of you are going to learn just by, you instead of doing this proportion thing, you're probably good at unit analysis in chemistry or physics or something like that. And if you have 3.2 kilometers and you want to convert it to meters, I mean, probably you can do that one in your head, but you could say 1,000 meters is 1 kilometer. So get rid of that, right? And then you know to multiply 3.2 times 1,000 divided by 1. You could do that unit analysis kind of thing here if you want, as a different kind of a method. You could do, you could say if I want 73 degrees and I want to get rid of degrees, I can multiply it by a fraction that's equal to 1. So if you kind of resonate with this unit analysis method, please do it that way. Do it some way that makes sense to you. If you want to change it, if you want to get rid of degrees, you can say I know that 180 degrees is equal to pi radians. Pi being a number, 3.14. The reason I would write this fraction this way is because I want to get rid of degrees, because I've got degrees here. If I put degrees in the bottom, they'll cancel out, right? So I can then just do 73 times pi divided by 180. Some of you will just intuitively say it's 73 out of 180 times pi, right? Because if you have 73 degrees being there, and just thinking to yourself, it's that fraction out of 180. And just kind of think, well, if this is 73, and all the way around is 180, I want 73 1/80ths of pi. And you can just do it, you could do it that way. I don't know what you want to call that, kind of the intuitive visual way. Intuitive visual way, I don't know. And then you can just make that in lowest terms if it happens to be one that you can reduce. Or you can just multiply 73 times pi divided by 180. I really hesitate to kind of do this from a rules kind of approach or a this is how you have to do it. I want you to find your own way to convert between degrees and radians, either kind of using a proportion, unit analysis if you like that. Really all you have to remember is the one conversion factor and then it's easy. 180 degrees is pi radians. If I wanted to do something else, like if I had 2 radians, or something, well, let's not do 2. Let's say I had a number like 2.3 radians. If I want to convert this to degrees, I could, if I'm doing the unit analysis way, I could multiply by radians on the bottom and degrees on the top. I know that pi radians is the same as 180 degrees. The reason I want to do that is because then those disappear. So I can just say it's 2.3 times 180 divided by pi. And it's that many radians. You can just go to your calculator, 2.3 times 180 divided by pi. Or, of course, you can write a proportion down and say 180 degrees is equal to pi radians. So if I want 2.3 radians, then just call this x and solve for that in your proportion. Okay, solve for this. You know how to solve proportions, whatever way you want to do it. Okay, you find a way that works for yourself. The answers for this are, or should be, where did I put the answers for this? Did I give you the answers for this? Perhaps I didn't. I will. The last thing that's involved here is this arc length formula. I'm thinking that if you have finished this, you can go on to looking at this arc length formula. This arc length formula is just using a proportion, kind of the same way that we just did there. Proportion. This arc length formula comes from filling in what you know about that proportion. The arc length formula is a way to calculate this length of this arc and how it relates to the other things involved here. I would like you to try and look at that and try and fill some things in here and think about how is the length of this arc here related to the radius and this angle, whether it's in degrees or radians. Both cases, the longer you make the arc, the bigger the angle is, or vice versa. The bigger the angle is, the longer the arc is. You can use a proportion and say 1 full turn in degrees compared to this angle in degrees should be the same as this arc compared to the circumference. Or whether you do it in radians or degrees, it doesn't matter. Proportionally, that's the same. If you're halfway around, the arc length is half the circumference. If you're this far around, well, whatever that angle is compared to that. We will talk about it formally together later, but I want you to try that if you haven't already done so. Okay?